yesterday, major was our MSA, box plot, and about the data transformation and all. So what exactly we have covered? Let's just have a quick recap. On the day 5, we covered the MSA. MSA is measurement system analysis, where we are trying to find out either my data which I am going to use for the analysis is reliable or not reliable, or is coming from the reliable source or not. So because every decision in Six Sigma we takes based on the data, if my data itself is not reliable, so then what decision I will be taking that may not be true. So it's important for us before we start taking any decision based on the data, we validate the data, and data validation we do with the help of MSA. We understood MSA for the continuous and the discrete type of data. Based on the two rules for the continuous data, your number of distinct categories should be greater than 5, and your total gauge anion percentage, which is lower is better, should be less than 30%. For the attribute agreement analysis or the attribute data, we learn about what? We learn about which rule? Accuracy, repeatability, and reproducibility. All three values should be ideally more than 90%. Then we understood the box plot, which divide your entire data into 4 equal parts. And these are called as in quartile. Interquartile range is quartile 3 minus quartile 1. And the length of the whisker is interquartile range into 1.5. We understood the yield calculation, where we understood first as in first pass yield. Then we understood about roll throughput yield. And we understood about classical yield. All right. So this was the discussion yesterday. Other than this, we understood about the data independence, center limit theorem, and data transformation. These are the things we learned. Now, today we are going to learn very, very important topic, which is your process capability. What is process capability? What is the continuous data process capability? In continuous, what is normal or not normal data process capability? If your data is discrete, then what is the binomial process capability? These are the things are the topic for today. And then we'll be jumping into the analyze phase after this. So before I start, let me take questions from anyone in case any one of you have any kind of question which you want me to clarify first, and then we'll proceed further. Guys, open for all your doubt, all your questions, all your apprehension, anything you have.
Just for information I need.
Yes, please.
Sir, like in production, in manufacturing, we can say that attribute data is kind of data like we do visual inspection for step marks, burr, chatter marks in chamfer. All these things come under attribute data, right? Where we just can say it's either okay or it's not okay.
Right, absolutely. Yes.
Okay, so and while doing study of this data, I need at least I need to study at least 30 parts and not
Absolutely.
30 attribute 30 what can you say properties,
data
right?
points. No data points, at least 30 samples you will be picking up.
Okay.
And if you have the 2 people, so which means each person in the first trial, they will be picking up at least 30 data points.
Okay.
All right. Any other question from anyone, guys?
Good evening, sir.
Yes, sir. Good evening.
And I have a can you quick recap around the box plot? And another thing, some my observation regarding the recording video. It is my observation, not complaint. It should be better if yesterday video recording was given to earlier. Because every day yesterday uploaded video recording around Indian time is 5 p.m. to 6 a.m. If you give earlier, then it will be better to understanding also for practice also.
Okay.
My observation.
Okay. I will pass your message to the backend team about that you need the recording early, and that's
But
always it should be as early as possible. So I will pass your message and will ask them to do earliest as possible.
because the every day the around 6 p.m. to 5 to 6 p.m. upload the yesterday recording. If you give earlier, then we can better practice to understand the.
I got your point, sir. Yes. Thank you. I will pass your message definitely. So in the box plot, you was asking, box plot help us to understand how my data is distributed around these 4 quartiles. Quartile 1, 2, 3, and 4. Quartile 1, which is means each of the quartile is holding 25% of the data. So here we have taken the example of the 200 data points. So how much is the 25%? 50 is the 25% of 200. So quartile ones will say that 50 data point from the minimum value to this value, there are in between 0.02 and 12.87, there are 50 data points are coming. If you arrange that data in ascending order or descending order. Then from quartile 1 to quartile 2, another 50 data point, which is 12.82 to 35, you have the another set of 50 data points. So if you see the difference or the window of operation for the first 50 data points, the range is only 12.80. Now, if you see the range of the quartile 1 and quartile 2, then the range is around 23 data points. So there is a higher variation here. If you see from quartile 2 to quartile 3, the range is becoming 36, which is much higher variation, which means as your data points are increasing, your variation is increasing. And if you see from quartile 3 to quartile 4, this is much higher variation. 242 is the difference. So that will tell you where is the maximum concentration of your data, where is your data is distributed. So by looking at the box plot, we'll come to know that which is the area where is the highest variability. So we should be focusing there so we can reduce the variation. If you are reducing the variation, that means my process will be more stable and the process will be more capable. That's what the objective of doing the box plot. So in summary, box plot divide your data into 4 parts. In each part, which means each of the quartile, and we'll see because data are count wise is same in each of the quartile. So we'll see what is the value starting and the ending value. So how much is the difference? The difference will call your variation in the form of the range. That's what is the box plot. And this helps you to find the outlier. So outlier is what? Outlier is less than the lower whisker or more than the upper whisker. What is the whisker? Whisker is your quartile 3. I have written somewhere, I think. Quartile 3 plus length of the whisker is your upper whisker. And the quartile 1 minus length of the whisker is your lower whisker. That's how we identify this. Okay. Let's understand about the next thing, which is the process capability. So what is the process capability? I think we have discussed process capability. Okay, I have already created a tab. This is your process capability. So let's understand what is the process capability. You remember on the day 1, we discussed about the sigma level, right? Sigma level is also your process capability. If you say sigma level of your process is, let's say 4, maybe let's say 6, 5, 4, 3, 2, 1. This is your what? Long term or short term?
Long term.
Short term. So long term sigma will be how much? Minus 1.5. So this is your one capability as in sigma level, how well your process is doing. That will understand by this. Another way of understanding this, you can convert this into the yield. Yield as in short term or yield as in long term. So how to convert sigma to yield? Again, I'm creating formula. Norm as dist, select your sigma 6, and here we go. So this yield is almost 100%. If you go with the decimal, after 7 decimal place, you will get a 0 value. And the similar way, you can get converted into the other value. Okay, 1 second. Okay. Now, similar way, we convert the yield into the long term. Like as 4.5, if you use the formula, you will get the yield here as well, which is 99.9997%. Similar way, I make you understand about how to convert into the DPMO. So what is the first? We'll see the defect percentage for the long term and defect percentage for the short term and the defect percentage for the long term, right? So what is the defect? Defect is always 100% minus yield percentage. So 1 minus this percentage if you'll do, that means this is your defect percentage. Similar way, you will have the defect percentage here, which is like this. If you want to convert this defect into the DPMO, so this is your DPMO long term and short term. Short term, let me write in the DPMO short term, DPMO long term. So short term, you have the defect multiplied by million, which is 10 power raised to 6 is your DPMO. Similar way, you have the DPMO as in long term. Now, another thing which I will tell you, which is applied most of the time in the service industry. Okay. Now, the similar way we talk about the process capability, which is CP. Generally, we use in the manufacturing. Why we use only manufacturing, I will tell you. So CP or CPK, if you look for the short term or look for the long term. So how do we convert this? This is ratio is 1:3 from the capability to the sigma level. So in case your sigma level short term is 6, this means if you divide this value by 3, that will be your capability, CP/CPK. This is what the expected. And the same thing if you do for the long term and you divide this by 3, then this will be your capability on the long term basis. So today we are going to learn how to calculate the capability here and how to convert that capability into the sigma or the yield or on the defect or on the DPMO. This is what we are going to learn. Now, why I was using the word, it's mostly used in the manufacturing, because generally manufacturing, you have both the side specification. If you have the one-sided specification, you can directly calculate the sigma level. But you have both the side specification, you want to figure out which side you have the most of the problem. So that if you want to identify that, then we will be trying to figure out that which side we should be focusing. That's what we try to identify with the capability. Okay, let's see. So what is the process capability? Process capability means how well your data will fit within given specification. How well your data will fit within the given specification. let's see, here is your, I'm deciding this is your, let's, there is a note like this. Let me, you are driving a car and this is your road. Okay. When you drive a car and this is your road, and let's say your car is here. Maybe you want to go with the driver, you don't want to drive by your own. And this car is going on the road. Maybe if I make two driver, one driver is this, one is this. So one driver is going like this, very well performing within the specification, not touching both the side, but is going like zigzag, like as the centering and variation I was explaining you. And the second driver is going like this, consistent, but is on the one side. So which driver you will believe more? Second one, because there is a consistency. So consistency means lower variability against the specification. If this person is driving like as this time is touching the road outside, or this time side is touching the road outside, then it will be very difficult for you. So there are two types of capability for the data. One is called as an inherent capability. And the second one is called as an actual capability. So inherent capability and actual capability. So what is the inherent capability? Inherent capability means how well your process can do. How well your process can do within the specification is the inherent capability. Actual means how well your process is doing. So one, how well your process can do, and the second, how well your process is doing. That's what is the inherent and the actual capability. This is represented, inherent capability represented by CP, and the actual capability represented by CPK, which is as good as your sigma level. If the sigma you divide by 3, you will get the capability. So CP we calculate with a formula is equal to your difference of specification, which is USL minus LSL, divided by the variation, which is 6 times of standard deviation. This formula you will be using to calculate the CP value, process capability value. Okay. Now, how you will calculate CPK? You will be taking the minimum value of CPKU or CPKL, which means process capability on the upper side of a specification and process capability on the lower side of a specification. Whichever value comes as a minimum, that's what is the CPK. Why we are taking minimum? Because we find out which side we should be focusing. Like as if you see this car example, one car is going on this side. So looking at this car, if you see there is a lot of space available on the lower side, which means probability of defect or probability of touching the boundaries is very less on the lower side, but it can easily touch on the upper side. So in this case, if I calculate my CPKU, which is on the upper side of a specification, that will be very, very low capability, because the difference from the specification and actual is very less. It can easily touch. But opposite to that, my process capability on the lower side will be very high, because there is a lot of differences there, lot of gap is there. I can easily pass my car from that. That's what the CPKU and CPKL. If you try to understand from the data distribution, let's say here is the shape I'm creating. So this is your data distribution around the center line. Where is the center line? Center line is, let's say, this. Now you have the specification value. Sorry, not this. Specification says this side is your upper side of specification. And this side is your lower side of specification. Looking at this, how well your data fits within the specification, what percentage of data is fitting within the specification, that is your process capability. Maybe as I was telling U and L, let's say this is your LSL and this side is your USL. If on the lower side you are continuously touching the boundaries, but upper side you are not. So in this case, your process capability on the lower side will be less, which means probability of defect will be high compared to the upper side. In other case, if lower side there is gap, upper side your defects are there, you are touching the boundaries. So in this case, your upper side you will have the low capability, which means the probability of defect will be high, while on the lower side not. If both the values are far from your actual data, which means there is no probability of generating the defect in any side, or if both the side gap is very, very low, your data is crossing the limit, which means both the side you are generating the defect here when the data values are going outside the specification. This is the fundamental behind the process capability in a practical way. Before I go for the statistical way, is this understood or not?
This is defect or defective?
Defects. We are here just talking about the defects. We do not use the term defective when we are talking about the capability, because we are calculating about the percentage of the data. Another example I say, now there is a road. I want to do, generally how you will get your driving license? Driving license you will get when you are driving on the standard road. And then you are driving on the actual road. So capability, what is the inherent capability here? Inherent capability means how well you are doing in the test. So test says that you have to drive on a 3-meter road and you are driving on the 3-meter road and you are very well passing, which is the test road. But when you are going into the actual road on the highway, how well you are driving there, that is your capability of the actual capability or the CPK. So CP means you are checking how well you can drive within the given specification. Doesn't matter you have been given the 3-meter road. It's maybe highway. It's maybe a test field. It may be anything. And how well actually you will be driving after learning the driving. That is what your actual capability. That's the way we'll differentiate between the CP and CPK. Okay. Now these are the formula. So now I am going to help you to understand this. Let us take one example. Maybe you bought a new air conditioner for your house. When you bought a new air conditioner, maybe for any of the company, then company that the salesperson or maybe the dealer is telling you, sir, my air conditioner is very good. It will give you not less than temperature of, let's say, 18, and it will not go more than 24. And this is the automated, what we call automated air conditioner. As per the weather, it will automatically adjust the time. Now you decided, okay, let me check the process capability of your air conditioner. You installed the air conditioner and you started measuring the temperature for next 30 days. So here, every day you are measuring the what is your temperature is coming at a particular time. Maybe in the morning, evening, or night, whatever you have decided, that you are going to measure the temperature. Just to find out how capable your air conditioner is to deliver the temperature within the given specification. And you have collected the data, let's say for how many days? 30 days, let's say we are collecting the data for the last 30 days. Perfect. And let me generate some random data. Here is your random data. You got the temperature between 19 and let's say 25. 24, okay. And this was the temperature. I just copy paste this as in values, make it to 2 decimal. Now you want to find out what is the probability of defect of my temperature. So you have the specification limit, you have the actual value. So first I will calculate what is my inherent capability. Is my air conditioner is really capable or not capable in delivering the temperature within the given specification. So for that we will be calculating CP value. So to calculate CP value, what do I need? I need USL, which is here 24. I need LSL, which is here 18. And I need the standard deviation as well. So standard deviation, if I calculate for this data, stdev dot s, let's say this is the sample data only I am taking. Select values and enter. So what you got? 1.44 is the standard deviation. Okay. On an average, how much I am getting? Because that I will need to calculate the CPK. So let's say average temperature of my air conditioner is around 21.61. Ideal condition, what average I am expecting? You take the difference of these and divide by 2, which means 24 minus 18 divided by 2. So ideal condition I am mentioned. Sorry, I did not the difference. Sum of these two plus divide by 2. I am expecting 21. So your ideal condition, you are expecting 21 and this is 21.16, which means let's understand this is your lower limit, which is 18, upper limit, which is 24, target value is 21, and where you are getting 21.61, which means you are getting the temperature on the upper side of the center line, which means the temperature you are getting somewhere here. Now this is more than or above the half part, which means there is a low probability of defect on the lower side of specification. Towards the lower side means 18 side, but the gap on the upper side is very low, very minimum. So means there is a high chance you will be generating the defect on the upper side. So the yield on the upper side of specification will be less than the yield on the lower side. This is the practically way I am telling you, because mean value should be 21, but it is shifted on the upper side of specification. So when it's shifted on the upper side, your car on the road is standing like this. There is a gap on the lower side of the car. You have a much space. You can easily move this side, but on the upper side, you cannot move. So there is a high chance that you may crash on the upper side, but there is a very low chance that you will crash on the lower side. That's what exactly by looking at the average value against the target value, you can figure out. Now let's calculate the CP. CP USL, which is 24, minus LSL, which is 18, divided by 6 times of standard deviation, which is 1.45. CP value is coming 0.69. Anything less than 1, because if you remember sigma level is 6, if you divide by 3, so my capability will be 2. Where the minimum expectation from any of the process is 1. And my capability is less than 1, which means not capable. If this value is, if CP is less than 1. Okay, not capable process. Now CPK is the minimum value of CPKU and CPKL. So what is the CPKU formula, which will tell you the probability of on the defect on the upper side? CPKU
mean minus
USL
minus mean
divide by 3 times of standard deviation. Because we are checking half part. So for the full, we were dividing by 6 times of standard deviation because here we're checking the 1/2, either on the upper side or lower side. So we are dividing by the 3 times of standard deviation. CPKL is your mean
Mean minus LSL.
LSL divided by 3 times of standard deviation. If we calculate CPKU and CPKL as per this data, so my CPKU will be 24 USL minus average 21.61 divided by 3 times of standard deviation, which is 1.45 into 3. On the upper side, you are getting CPKU, which is only 0.55. Again, less than 1, which means there is a lot of chance of what? Defects. Let's see on the lower side, what are the chances? So lower side is your mean value minus lower specification limit, which is 18 divided by 3 times of standard deviation. On the lower side, I have value is higher. So whichever the side CPK value is high, which means the chance of defect is low compared to other. So in this case, if I say 0.55, which means there is a chance of high defects compared to CPKL, where the value is high, so the chance of defects are low. They are inversely proportional to each other. If defect is high, then capability is low. If capability is high, then the defect will be low. If you want to convert this capability value into sigma, which means Z value. So Z is sigma, Z USL, and Z LSL. So I was telling sigma to capability ratio is 6:2, which means 3:1. 6:2 means 3:1. So if the same value CPKU you got, you multiply by 3, you got the sigma level on the upper side. And if you have the CPKL, you multiply by 3, you got the sigma level on the lower side. Okay. Now you got the sigma, so you can convert into the probability or the yield. What is the expected yield if this is your sigma? Equivalent to yield USL and your yield LSL. How do we convert sigma to the yield, guys? Anyone?
Norm DIST.
Yes, norm dist. Perfect. So upper side norm S dist and upper side value is 1.65, which means this is expected 95.07% time you will not miss upper specification limit, which means how many times there is a chances as per the data that you will miss the upper specification? 1 minus 95.07, which means around 4.93% chance that you may miss upper specification limit, which means temperature of the air conditioner will cross 24 degrees centigrade. Let's check for the lower side. What is the yield? Yield is 2.50. If you convert this, which means 99.37%. What does it mean? There is a chance that 99.37% time you will not be missing lower specification, which means temperature will not go less than 18. So how many times you may miss the lower specification, which is your 1 minus yield on the lower side. It's around 0.63% you will miss. So in the upper side, you are missing 4.93%. Lower side, you are making 0.63%. So how many times, what are the total chances or total defect? As per this data, you can observe that will be your sum of both the side defect, which means you have the lower defect plus upper defect. So total 5.56% you can miss. Then what is your defect free time? Means how many times you will not miss? That means simply 100% minus this defect percent is your the time when you will not miss, which is your final yield. So if I do 1 minus this value, 94.44%, you will not miss neither lower or the upper specification. So what is your sigma level now? How you will calculate sigma long term? Now you can convert, and what is the formula I will be using in Excel? Norm sine V. Select this probability and here we go. How much? 1.59 is your long-term sigma, which can be converted into the short term. What will be the short term? Anyone? Long term plus 1.5 will be your short term. That's how, guys, in a simple way, we calculate the process capability, and I make you understand about short term, long term, lower, higher, CPKU, CPKL with this example. Ask me the
Sir,
question.
can you just repeat this CPK, how we got this 0.55 and 0.83 for CPKL? Is it like USL minus mean divided by 3 into
Can you
standard
see this
deviation?
formula which is highlighted here? Yes, exactly the same.
Yes.
So this formula I am using. Basis on this formula I got. So USL is 24, average is 21, divided by 3 times of 1.45, which I am using exactly. I kept the formula here. I did not remove. So all calculation you can, when you are repeating, you are practicing, you will very easily understand. Right? You can see 24 minus 21.16, 3 times of 1.45, which is here.
Right. Thank you.
So that formula I'm using.
Okay,
Now
I
you,
have a question. Sorry, I have a question. Here we've already identified that the process capability and that the process is not capable. But
yes,
then the actual capability is that it is capable somehow with a percentage of defects, possible defects.
this is
So-
point, 1 minute, Muna, 0.55 here. Lower
Okay.
side 0.83, which means it will be delivering you the data only. Upper side is 95.07. On the lower side, 99.37% within specification, which means how much is the chance of out of specification? These 4.93 on the upper side, 0.63 on the lower side. So total defect, what you can get, the probability is around 5.56%. If you can tolerate the 5.56%, you can see your process is capable, especially if
Okay.
you work in the medical devices, hospital-like profession, you are working in automobile and all critical segments. So probably you cannot tell, you cannot do this. Okay, you will not be
Okay.
tolerating.
Okay, because I thought if we identify that CP is not capable, there would be no point of assessing the actual capability because the process is not capable.
No, we'll be assessing that as well. Maybe your as per specification, you are performing good, which is the window. Because here I was talking about, this is the sample.
Yeah,
I'm giving you the sample road and you are driving well. It seems you are capable. But when actually I'm asking you to drive on the highway, probably you are fail here. You have a fear with the highway or anything else. So maybe you are driving good. If you are able to drive good on the sample road or on the test road, then only I can ask you. If you demonstrate your skill, yes, you are a good driver, then only I will give you my vehicle you to drive on the highway. So we should be
Okay.
assessing both.
right, okay.
Question before I move to the Minitab part.
Sir, so according to this example, if
Hmm.
our process is not capable, so
Hmm.
what actions we should take to make it capable? Means how can we manipulate data? Means what type of actions? Whether we have to be very close to target, right?
Yes. So what it says here, as I was telling, you see this, you are performing on the upper side of the line. If you see this orange line, this is your upper
Yes.
side and lower side. So there is a
Yes.
high chance that on the upper side, you may skip compared to the lower side because you are driving on the upper side of the road.
Mm-hmm.
So first thing, you should be moving into the center like this.
Okay. Okay.
Once you move into the center, both the side specification, you are driving, this is your average value is coming, but you are driving zigzag, which means your standard deviation is high. So then you have to bring the consistency in the center itself.
Mm-hmm.
That's
Okay.
what you have to bring. So like as this air conditioner, first it is going on the upper side. So you have to figure out why my average is on the upper side of a specification. Check what are the factors are not working. And then why your air conditioner is fluctuating. Sometimes is giving low temperature, sometimes is high temperature. What is the reason? Is this compressor is not working? Is there is no gas in the compressor? Is this power fluctuation? Is this motor is not working, or so many of the things, right?
Right.
So those things you will be figuring out and fixing them permanently.
Okay. Okay.
All right.
Thank you.
That's what
Yes.
practically we'll do. And that's the objective of doing the process capability. It will give you an idea that which side and how much we are supposed to work. All right.
All right. All right.
So let me take that same data and I will help you to understand the capability in the mini tab now. So we are going to do the capability. This is the capability data I have just generated. As I was telling, the capability you are going to learn for the normal, not normal, binomial and Poisson. So I just, as of now, I just explained you about the capability. Still, I did not go what is normal or not normal, which we are going to understand by the mini tab. So let me open your file. Mini tab file. Is this new file open? Where is my old file? Yes, this is the old file. So here I am adding one more sheet as an capability. Pasting this data. Oh. Where is my data? This data. All 30 days data I have here. Done. You already know the specification, which is the lower specification is 18. Upper specification we have taken as in 24. Okay. Now, first thing, as I was telling here, normal and not normal. So you need to understand what kind of data is distributed. So to identify my data is normal or not normal, which analysis I will be doing, guys?
Anderson-Darling.
Yes, Anderson-Darling I will be doing. Go to stat, basic statistics, and here is the normality test. By default, it will be selected Anderson-Darling. Okay. So Anderson-Darling is selected here. And now if you look at the result, what do you interpret? Is this data normally distributed or not? Guys?
Not
Data
normal.
outside limit.
No.
It is
This
not
is normal because p-value.
Yes, sir. P-value is more than 0.05.
If p-value is greater than 0.05, this means data is normally distributed. It's not that easy to remember everything so soon, but yes, slowly, when you will be practicing, you will learn. So whenever the p-value of the Anderson-Darling test is greater than 0.05, then data is normal. So I found that my temperature data is coming as a normal. So now I can go and select the normal capability option in the mini tab to do it. How will we doing? Let's understand now. Okay. So here is my mini tab. I will be going to stat, quality tools, capability analysis, and here is the option normal. Click on this. Single column is your data, which is temperature. Subgroup size by default as in 1. Specification is 18 and 24. Now what you want to see in the options, you can select parts per million, which is the DPMO, or percentage, or in capability or sigma level, you can select any, which will give you the long-term sigma. So let's select as in parts per million DPMO and the capability CPCPK first, and click on OK and click on OK. So this is the kind of result you are getting, where on the lower side you have 0.83, where on the upper side you have the 0.55, and where on the overall inherent capability is 0.69. Can you see here? Inherent 0.69, lower side 0.83, upper side 0.55. And if I see what we calculated manually, you have 0.69 inherent capability, 0.55 on the upper side, 0.83 on the lower side, which is what we have calculated here as well. So this will give you the same output which we calculated by the Excel. Sometime it may change. It will depend on the variability on the data, because Minitab is much capable, which will take all consideration into the picture, while the Excel may not do that. So this is the way we do capability. And here is what actual observed defect is 0, 0. No defect you have observed, but you are expecting overall defect is around 6296 on the lower side of specification and around 49326 on the upper side of specification. From where this is coming? This is ppm, parts per million, right? If you convert your data into the ppm, which is the defect data you have, so ppm means this defect multiplied by 10 power raised to 6. So you will get the same defect, right? 49326 and 6296.
What is this
6297.
potential capability?
1 second. 6296 and 49326. What exactly you are getting here? Mayur, you joined the session when I was explaining about this. Potential means how well, like as you are giving the driving test. So how you are driving in the driving test, which means your process, you are not into the actual process, you are doing the simulation, and simulation as per the data is how well you are doing, is your potential.
It means
Inherent.
inherent capability.
Inherent. And what is the actual when actually you drive on the highway?
But inherent capability, we calculated for that air conditioner example, it came 0.69, right?
Mm-hmm.
0.69,
Let's
but
understand another thing. Just see this, because this is not taking where is your center value. 24 minus 18 difference is 6. Divide by 6 time of industrial deviation, 0.69. If you, instead of taking 24, you take this 30 this side and 24 this side. Maybe let's say 25 this side. So 30 minus 25 difference is 5. 5 if you are dividing by 6 time of standard deviation. Then your capability will be almost same. But you see there is a lot of difference from 18 to 24 and 25 to 30. And the same thing if you do, instead of 30, I am having 50 here and I am having 45 here. Still my capability will be, because this is telling you that within this variation you can sustain or not sustain. This variation actually where it is, air condition requirement is not 45 to 50, but your system is telling within 45 to 50 you can perform like this much of variation. But my actual requirement is that air conditioner should perform 18 to 24. That's how I will say this is inherent and this is the actual. Now it's clear?
Yeah, clear. But can you go to the graph?
Okay.
This potential within capability CP is 0.75. I'm asking about what is this?
No, don't look at the potential within. Potential within, you look at the overall as of now.
Okay, that I
That's what.
understood.
That is what we are calculating. Potential means, which is what I am telling here as well, because I am calculating based on the actual data. I have given the
Okay.
same specification, same data. So you will be looking for the PP, which is coming as in 0.69. Potential means if you continue in the similar way, anywhere you bring this process, this can go up to 0.75, which means your process has a potential that you can reduce this variation further.
Okay.
This is what it is telling. So potential means this what your process have that can perform in future. And this is your overall means as of now, how it is performing.
Okay, understood.
All right.
Right.
So that's about the normal data. Many times in the service industries, you do not get the normal data. So when you have the one-sided specification, you can directly calculate the sigma value. Let's see, I did not tell you still the sigma calculation for this data. So if I edit this graph, Control E, you can use as an edit, go to the option, and you can select the percentage as well as the benchmark sigma. Instead of parts per million or capability, you can use percentage or benchmark sigma. And if you click on OK to this, you will be getting the sigma value here. How much? 1.59, 2.50, 1.65, which is as good as what we have calculated. So you see 1.59 overall sigma and 1.65 and the 2.5 is the USL and LSL, which is listed here. Potential is up to 1.76, 2.72 or 1.80. So you can just change and you will get your sigma level as well in this. Where is the option? Edit, options, and select here benchmark sigma and the percentage data. You will get it. So this is about the capability of your data when your data is normal. Many times you have not normal data. Last time I was telling you, I think last week, individual distribution identification. Remember? Let's generate some not normal data first. And we wanted to find out the capability. So let's say this is your quality. Quality is always one-sided. And I'm looking for the quality, let's say calc, random data, and log logistics, log normal, let's say log normal. You want to generate the data as an 100. Location is around 90. Scale threshold, let it be as it is. Store in the column as in quality. No data point. Why? 0.90 if I do. Yes, you got it. Okay, this is the data I got. Now I want to calculate the capability. My quality is always higher is better, right? And let's say my scale is that minimum 90% or 0.90 I want to achieve. Or let's say this is the production. Productivity. One-sided specification you have. First, you will check the data normality of this data. Data is normal or not. Then if you see how stat, basic statistics, normality test. Select your productivity, click on OK, and you will see that p-value of your data is less than 0.05, which means data is not normally distributed. Data is not normally distributed. So what to do next, guys? Can somebody help me? What is the next thing?
Transformation.
No, transformation is never recommended. First thing we will try and identify until unless this is not something critical to you. Matlab, this is something when it's a do or die situation, then only you should do transformation. Otherwise, it's not recommended.
We have to check it is due to special cause or not.
Yeah, that will come because not normal. So there is a special cause. First and foremost thing, if it is a not normal, then which distribution it is following. So then we'll be doing the individual distribution identification of this data. How? We'll go to stat, quality tools,
Individual.
select individual distribution identification. So if it is a not normal, then which distribution it is following, it will tell you. You can select your data, which is your productivity, subgroup size 1, and do not specify anything, let it go. Use all transformation and distribution. So which are the values you should not be looking for?
Sorry.
Which are the values as an output you should not be looking for in this output? If you remember, let's say now, you should be able to remember. This is my table.
The extreme, if I remember,
I will not be looking for transformation.
transformation and extreme.
X.
I will not be
for
looking for normal. I will not be looking for any of the
Extreme.
extreme value. Other than this, whichever the p-value is highest,
We have to.
that is my
specify that.
distribution. So now which p-value is the highest you can see here?
Highest.
Three parameter.
Three parameter.
Yes, 3 parametric variable is the highest. This is the highest value. So that is what my maximum probability of the distribution, which is the probability value is high. That is your probability of distribution is high. So this data is following a 3 parametric variable distribution. I want to check the this capability now. So first let's check the graphical summary and let's understand what is my probability variability in my process from where to where. So I see my minimum value is going as in 0.17, maximum is 22. Average value is coming approximately 3.93, which means in the lower side of the data is maximum values are coming, right? You want to set a specification. That specification is your average. You are looking for the 5, suppose, and value may range from 0 to 10, and you want to figure it out. Or maybe 5 is there, that value should be from 1 to plus or minus 4, which means 1 to 9. So what is the capability is coming for this data? Let's see here. So if is my data, my lower specification limit is 0.1 of LSL1 I am giving 0.1, and the upper specification limit is how much? 0.9 I am deciding. Okay, let's remove this higher is better part. Now I want to calculate the capability. So what is my data distribution? 3 parametric variable. I'll go to stat, quality tools, capability analysis, non-normal, because data is not normal. When you select on this, select here the fit distribution. And what is that? 3 parametric variable. So I will be selecting this option from here. Lower specification 0.1, upper specification 0.9, and the data is your productivity. Options the same, capability, parts per million, benchmark or percentage, let it be. And now you click on OK, and you will be seeing the graph of the not normal capability analysis. It's not able to calculate PP or PPL. Why? Because the distribution from the 0 values are going more than 50% are on the less than the specification. So there is a formula in Excel. if your probability is 50%, then your sigma is 0. If your probability is more than 50%, then sigma is positive. And if your probability is less than 50%, then sigma is negative. So here is your probability. If I say this is your 55%. So what is the sigma? Norm dist. If you use the formula, no RMDIST. Not norm dist. Norm
Sine
Sine V.
no. Norm as dist. Norm sine we have used. What is the formula? Norm dot dist. I think it should be. Just a minute. The norm dot dist. No, norm dist. only.
Norms. SS. Norms.
This norm dist. There is a formula. I'm missing that formula.
SI
No, sir.
NV?
No, that we have used. Norm sine V, norm as dist we have used. Norm dist it is not given. Yes, norm as dist we have used. क्या था? Norm sine V, Norm sine V. Even I got confused. Sorry. So this is taking your probability, and that will tell you the sigma. So you see, if value is greater than 50%, sigma will be positive. Right? If your value is less than 50%, if it is exactly 50%, sigma will be 0. If it is less than 50%, then sigma will be negative. Let's say 49%. If it is 49%, then sigma is coming to negative. If you are taking 51%, then sigma is positive. So it is not giving you the capability because it's a not normal data. Probability of getting the specification less than specification is 0. For on the upper side is more than 50%, which is 1,31,000 out of a million. And how much is the 50% of million? 5 lakh, right? 500,000. So that's the reason this is not at all giving you the capability here. Because it is a negative. PPU and PPK you can see. So this is the way we perform the capability of the not normal data. Now we are going to learn to understand the capability of binomial or Poisson data. Discrete capability. So you have two types of data. One is binomial and the second is Poisson. Binomial means you are looking for the defective percentage and Poisson means you are looking for the defect percentage. Okay. Suppose here is your production. On the daily basis, you are doing some production and the production data is coming approximately in between 250 to 310 is your production is happening every day. You have the data for last, this is 20 days data of the production. You want to figure out how much was the total defect we have observed based on the opportunities and what is my defectives I got in that data, and you want to convert in a capability from the Minitab. So let's say on an average daily basis, you have the defective minimum 5 you have, maximum 15 you are observing. While the number of defect you have, approximately in out of these 5 you are getting at least, let's say 10 to maybe 25 defects you are observing out of this production. And here we calculate. So we got the data. I just copy paste this data as a value. I will be first calculating all. What is my total? So if you see, this is the total. What? Production, total defectives, total defects. Now I will be calculating the percent of the data. So if you see percent defective, 202 divided by 5524, which is around 0.03. And if you see percent defect, this is the value you are getting, which is 6.061. Convert into the percentage, so this value you have got. Out of this, if the percent defect you have, then what is your yield? How do we calculate? 100% minus defective is 96% and defect minus is 93.360. So by this data, what is your sigma level? Is equal to norm sine V. 96.34 is equal to 1.79 sigma and 93.90 is equal to 1.54 sigma, which is your long-term values. How to calculate this in the Minitab? The exactly same value you will get, but in the graphical format. How? You just copy this data, production, defect, and the defective in the Minitab. Here we go. This is your discrete capability. I paste this data. So you have the production and defective. So for the defective, which capability we do? Binomial. Go to stat, quality tools, capability analysis, and here is the binomial is the option. Click on this. Defectives are this. Sample size is production. That's all. Click on OK. And you will see the capability in this format. You can see that your ppm level 36568, defective percentage 3.66% with a confidence interval. Sigma level is 1.79, right? You can see 1.79 is the sigma, third row from the bottom. What exactly we have calculated from the Excel as well. So this is the way you can see your graphical view of your binomial capability. Now, how to see the Poisson capability? Poisson capability we calculate when we are looking for the defect rate. Stat, quality tools, capability analysis, Poisson. Defects are this, sample size here,
Production.
that's all, and just click on OK. And here is your defect rate. How much? 0.0610 out of 1, which we calculated in Excel as well, 6.10%. Sigma is 1.55, which Minitab will not give you because Minitab has the limit on this Poisson capability. Minitab do not give you or don't give you that information what we can get from the Excel here for this particular capability. So sometime Minitab is good, give you lot of information. Sometime Minitab is not that great, what Excel can give you the information. So here is your Poisson capability graph. Now, this is about the capability, guys, which means how well your process is doing. From my side, I am done from the capability as well as for the measure phase. Open for any discussion. Before we go for the discussion, I just wanted to take the questions. Sorry, before we go for the break, let me take the question. And once after the break will come, we'll start the analyze phase. Yes, please. Any question for me? till here?
Pankaj, I have one question.
Ji.
We are calculating in Excel. So how we are getting in final assessment or exam? Which type of
You in the
question we-
final assessment in the exam, you may get a question like as you have what is your number of like as in this case, this is your total production, this is your defects are given. What is your capability in terms of the sigma level? So for that, you need to use your table. Like as in this case, if my yield is coming 96.34%, right? I was showing you one table, Z distribution table.
Right.
So 96.34 correspond to what sigma level? Let's see here. 96.34, 95, 96 to 327. Yeah, approximately 1.79 sigma. That table you can use as a reference.
Okay. Thank you.
No problem.
Sir, actually, I'm not concerned about exam and this passing the exam. I'm
Mhm.
concerned about how, where, and how I can utilize that on my day-to-day life. Because
Yes.
as of now, it's like a rocket science.
Sir, reason is all about the practice. You start doing the practice. One
How
topic
and
you
where to start the practice? I'm confused a bit because
you have
like,
my notes. 1 minute. You have my notes. This Excel sheet.
yes.
Daily basis you start with the one tab and practice till the time you become expert. Give 2-3 months for yourself to do the practice. Maybe in 2 to 3 months you will become expert. If continuously daily basis 1 hour you are practicing.
I'll start doing that, but I was confused what to do because I was not aware about anything. Now we are trying to learn, and we have learned a bit, but then the understanding and the concept is a bit, not alien now. But so I'm sorry because I understand the USL, SL, all these things now. But starting and where to start is like I'll start doing from today. Let's see where I'll end up.
Right. So, sir, this all depends on the practice. If you do the practice, you will come to that level. As I was telling, I'm doing the practicing for more than 16, 17 years. Still somewhere, sometime I will get stuck and I will figure it out how to come out of this situation. So Six Sigma is a deep ocean. You will try to go into this. You will try to become expert. You may not become perfect, but you will definitely will become the expert or the person that you will know everything about that.
Mr. Pankaj,
Yes, please.
so basically, we will finish our class by next week, and then what will we do? We will have to register for exam and do the projects, or how?
Yes. You have to register for exam, pass the certification exam, and do the project as many as possible. And I told you the source of the data, which is the kaggle.com, if you remember.
Yes.
Right?
So basically, we will just need to register for exam whenever that we are convenient, and then we do the practice with the Kaggle, the website, and then we submit our project using the Kaggle data, and then you will evaluate and mark, and we will certify. Is it that simple?
You can get certified without submitting the project as well.
So nice. Okay.
You just complete this training, pass the assessment, and I have a confidence the way I'm explaining, you will definitely pass the assessment. You will remember all these things.
So
Yeah, I
the
Once you
assessment
remember you
test will be
already.
objective type.
Objective type questions will be, which you need to select the right option through the online assessment.
Would we get some practice papers so that
I will do on the last day.
All right, thank you.
And you can search Six Sigma practice question on the internet, and you will get many websites. Like I'm searching Six Sigma practice exam questions. So you have the Simply Learn 100 exam questions. You have this website, Six Sigma Institute examples, Six Sigma certification test, study.com, Six Sigma study circle, and many of the websites are there, which is helping you. I hope you got it, guys.
Yes.
Yes, great.
Yes.
Yes,
Thank
sir.
you.
All right, so just do this, though I will be discussing one of the question paper on the last day of the session. Once all the revision and everything is done, so that you will be assessing yourself and I will be assessing you as well, that how much you could retain. Okay, so question for me, anyone, about the any capability or any other thing, whatever we have discussed today?
Pankaj, I read somewhere that many of the companies take the process capability benchmark to 1.33, right?
Yes,
So,
yes.
can you explain about that?
1.33 as the ratio to the capability of sigma is 1:3, right? So if your
Okay.
capability is 1.33, which means your sigma will be this value multiplied by, ratio is 1:3, so multiply by 3, which means 4 sigma. Which means how much is the yield you are expecting is equal to norm S dist, and the expected outcome will be around 99.99.
99.97.
So what is the defect you will have?
0.1.
Which is around defect you are getting in the, sorry, 4 digit, third digit. So this is the meaning of the 1.33 capability, sir, practical meaning. So this means they wanted to go almost defect free, which means they want to go for the zero defect. If they want to go for the zero defect, then minimum capability will be 1.33, which means what is the chance in 100? You are having 0.003, which means if you want to see the chance in 100 number of defects you will get, so this value, if you multiply by 100, which means not coming. If you multiply by 1000, then it's still not coming. If you multiply by 10,000, then it's still not coming. If you multiply by 100,000, then 3 defect.
Hmm.
So 100,000, which means 1 by 10 million, you are having defect is only 3.3. That's what is the expectation level by 1.33 capability.
But minimum requirement, it should be 1.
There is as such no requirement, sir. It will depend on the process to process. When you are serving food in a restaurant, how much delay you are doing than the committed time, or pizza delivery, you can tolerate the capability. Even 50% of the data is delivered on time, 50% is delayed by 2-3-5 minutes is okay. But the same thing when doctor is doing the heart surgery or bypass surgery, they cannot tolerate not even a single case out of 10 million. So it's all depend on what is the criticality of your process, and basis on the criticality of the process will be deciding what should be my ideal capability. Like as if doctor is doing the bypass surgery, they have no chance of making any error. Right, sir?
Right.
Okay. Any other question? No? Okay. So guys, we can take a break now for the dinner, and then we'll meet again after 30 minutes. And after 30 minutes, when we'll meet, we'll be starting about the analyze phase. So today in the analyze phase, I am going to explain you what are the different type of statistical analysis we perform in what condition. And once we understood this, then we'll be going for the all these analysis in the next week probably. If time permit, I will give you an introduction to some of them today itself. If time doesn't permit, then we'll be doing these analysis in the next week. All right. So as of now, I am going to just for a break of 30 minutes and let's start, and I'll see you in 30 minutes from now. Thank you guys. Thank you so much.
Thank you.
Thank you.
Hey guys, I'm back too. Thank you so much. Jane, answer to your question, still I did not identify why there was a difference in the Excel and the Minitab. I did not do that work. So now we are going to start the analyze phase. In analyze phase, the main part is your hypothesis testing. I hope everyone is remember what is the hypothesis.
Assumption.
Yes, assumption validation, which we have discussed. So which are the kind of hypothesis analysis you will perform? That will depend on your data type. Like as it's a numerical or non-numerical. This is your data type. It will depend on the distribution of distribution, may be normal or maybe non-normal. It will depend on how many categories you have. You may have sample data versus standard you are validating. You are validating two sample data with each other, or you are comparing three or more than three data set or sample data with each other. It will depend on what is your y variable, this is the nature of y, and it will depend on the nature of x as well. So as I was telling, your data can be numerical or non-numerical. So your y may be numerical or non-numerical, and the similar way your x may be numerical or non-numerical. Now it will depend on, are you looking for the variability in the data or the validation, or you are looking for the centering validation of the data. So basis on all these factors, I will be selecting my right statistical test. So how exactly your statistical test will work? That will always compare in hypothesis testing. Your statistical analysis will always compare the confidence interval. And what is the confidence interval? Whichever the metric you are comparing mean, you are comparing median, you are comparing standard deviation, you are comparing proportion, you are comparing defect rate. Whatever you have that value, here an example I am taking mean. So mean plus or minus margin of error is equal to your confidence interval. So if you are comparing median, so you will be comparing the confidence interval for the median. If you are comparing standard deviation, then you will be comparing the standard deviation plus or minus margin of error of standard deviation. That will be your confidence interval. So what we want to compare, basis on that will be deciding that the way to calculate the margin of error, and that centering or the variation, whichever the metric is, plus or minus margin of error will become your confidence interval. How exactly it will work, let us understand with an example. So here I will be explaining you about, let's say you have some specification, or let's say first sample when the sum comparing the, let's first understand with the one simple example. This is the first thing I'm going to explain you, sample data versus standard. Here is the sample versus standard when you compare, which means you have the one-sided specification. because you have a target value and you are comparing your sample data. So in the one-sided specification, maybe your sample data is coming like this. This is how your sample data distribution is there. And your target value, suppose if it is higher is better. So it is here. This is your target. If any part of yours, so as per this data, the center value of this data is this blue line. Let me change it to the green line. But this average value as per the theory of confidence interval may be ranging from here to here as an upper side, or maybe here to here as an lower side. So ideally or mathematically, average is this green line, but statistical average of this data is from here to here. So when it is comparing one-sided, it will always compare the confidence interval with the target value. Now, your null hypothesis will be when it's not overlapping. And null hypothesis means overlapping. Sorry, there is no difference, overlapping. When it's a overlapping, alternate will be, which means there is a difference. Alternate means there is a difference when it's not overlapping. So looking at this target value, higher is better. Here is your observation. Are they overlapping with each other? Guys?
No.
No.
No. There is a clear gap created between these two. Like this is the gap. So they are not overlapping. So in this condition, this is a null hypothesis. And in the case of null hypothesis, your p-value will be greater than 0.05. And after reading the p-value, I will decide this is null or this is alternate. If your observation is moving like this, are they overlapping now?
Yes.
Yes. So in this case, your p-value will be
Less than
equal to 0.05. And basis on, once I look at the p-value, if p-value is greater than 0.05, then I will be deciding that they are overlap. Null hypothesis, they are overlapping with each other, which means they are same. If they are not overlapping with each other, so which means basis on the p-value only, I will decide that they are not overlapping. Excuse me. Alternate hypothesis will say p-value is less than 0.05. So they are overlapping here. If this value, suppose this is the target, here you will say you are meeting the target. Statistically, mathematically may not, because this green value is away from the blue line. If this value goes here, mathematically, you are more than the target. Statistically, you are meeting. If this value goes here, there is a difference or no difference now?
Difference.
There is a difference, but this difference is in your favor. Why? This was your target, suppose 80. And the minimum value you are getting as an 82. You have achieved more than target. But in statistical function, this will come as an p-value less than 0.05. So here you have to be very, very careful. As I was telling, decision errors. You will make a decision error as a false positive or false negative. So this decision error is going to be false negative. If you will say the p-value is less than 0.05, which means there is a difference. Yes, there is a difference, but this difference is in your favor. Why? Because you already crossed the target level. So then you have to be careful. Okay. You have already crossed the target level, so that difference is good for me. But if your actual observation is below the target, when your higher is better, and this difference, if it is coming, so this is not in your favor. That means here is a difference which you need to take some actions, further improve the process. That is what the one sample with the standard. In case you compare two sample data with each other, similar we will be doing this. Like as this data you have, This is my 1 sample data and this is my 2 sample data. So if the 1 sample and the 2 sample, they are not overlapping with each other like this, so then there is a difference. This is a case of alternate hypothesis. If they somehow overlapping with each other like this, so the area they are overlapping, basis on that your p-value will come. And if they are overlapping, this is a case of null hypothesis and p-value will be greater than 0.05. P-value will be greater than 0.05 from here to here. So this is the total range. I start from the data from here and I finish it till here. If I pick up this, so this value is going from here to here like this, right? So this is the complete area which will be your null hypothesis. In case there is a difference comes between these two, like as now the gap is created. Because of this gap, it will be your alternate hypothesis. All right. If you compare more than 2 samples with each other, again, I will be comparing the similar way. So you have these 2 data set. Here it is pasted. And here I am pasting another 1 more data set. So if I see, guys, let's say delete one. This is the picture you have. Tell me, in this case, this is a null hypothesis or alternate or why?
This is null because it's overlapping.
Okay. Any other thought from anyone? Anyone, guys? This is an alternate hypothesis. This is not null. Why? I will tell you. Let's say this is 1, 2, 3. Sample number 1 and 2 are overlapping. Yes, null hypothesis.
2 and 3 are
Sample number 2 and 3 are overlapping. Yes, null hypothesis. But is the sample number 1 and 3 are overlapping?
No.
No. So null hypothesis says all are overlapping with each other, all are same. Alternative will say at least one is different. So in this case, 3 is different from the 1. So that's how in this case will be your alternate hypothesis and p-value will be less than 0.05.
But that was not mentioned earlier.
I mentioned 3 or more than 3 sample. If
No.
they are same, they will be overlapping. If they are different, then they are not overlapping. Yes, please. What is your question specific?
I was saying that, you know, like when null was mentioned that on the, if you can move the cursor up side, up.
Null, I said
Overlapping.
overlapping. Alternate, I said not overlapping.
Yes.
So this is 1 and 3 are not overlapping.
Okay. So the condition is everyone has to overlap to everyone, each
Yes.
and every data.
Null means there is no difference. So anywhere there is no difference is a null. Alternate means there is a difference. So if anywhere you found any difference, that means it's an alternate. So at least one value is different in the alternate. If none of the value is different from each other, that means it's a null. Okay. Any doubt, sir? Further?
No, sir.
No? Okay. Now let us understand the decision errors. We make decision error, like as last example we were discussing. We see this is a alternate hypothesis, but we got confused and we are telling it's a null. So decision errors, it will again depend on what is your assumption, what is your actual. Basis on that, you will be deciding there is a difference or not. Basis on the difference, the p-value will come. And basis on the p-value, you will be taking your decision. And then the decision error will happen in case you are not taking the right decision. Okay. Let's say I talk about this training as an first example. When we started this training, your assumption was that training will be good. Actually, when you attended the sample class or till today, do you found that training is good? Nobody is speaking.
Yes,
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 yes.
yes.
Okay. So training is good. Assume. Assumption was training will be good. Actually, training is good. Is there any difference in the assumption and actual?
No.
No. So when there is no difference, then you will see the p-value, and the p-value will be greater than 0.05. So what is the hypothesis? If p-value is greater than 0.05, what is the hypothesis?
Null.
It's a null hypothesis.
No.
And now I ask you for the feedback. Then guys, okay, please give me the training feedback. And you people are giving me the feedback as in training is good. Actually, training is good. That was your assumption as well. Feedback is also training is good. Are you making any error in giving the feedback?
No.
No error. So you are not making any decision error. You are taking the right decision by giving the correct feedback. Second case, assumption training will be good, but actually training is not good. Is there any difference between assumption and actual?
Yes.
Yes, there is a difference. So I will say there is a difference. So when there is a difference, what will be my p-value? Less than equal to 0.05, which means which hypothesis is this?
Alternate.
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 If it is a, and now I ask you for the feedback, and you are giving me a feedback, training is not good. Are you making a right decision? When actually training is not good, and you are giving me the feedback, training is not good. Are you making a right practical decision?
Yes.
Yes. So there is no decision error. Perfect. Now let's understand the situation when you will make a decision error and what do we call this? Training will be good was your assumption. Actually, training is good as well. There is no difference. P-value is less than 0.05, greater than 0.05, and then null hypothesis. And I ask you for the feedback, how was the training? And you people are giving me a feedback, training is not good. Are you making a right decision here?
No.
No. There is a decision error you are making, which means based on the statistics is telling something else, which means training is good. But practically you are telling training is not good. So that is the decision error you are taking. And this decision error is called as in type 1 error or alpha error, which is also called as in false negative, or this is called as an producer risk.
Is the actual based on the capability?
Yes, based on the actual result, what you see. When you observe the data analysis you have done and you are seeing the result, based on the result, say you are doing the, what is the data you have collected, you are doing the statistical analysis. And basis on that, you are taking a practical decision. So you have already done the analysis, you have attended the training, you have the data with you, and you are assuming your assumption was training will be good, and actually you found training is good.
Okay.
But when somebody asks you how was the training, so you are taking your practical decision to tell them. You are not doing any statistical analysis here, and you are telling training is not good, which means against the statistics, you are taking a different decision. Which statistics telling different, practically you are telling different or doing different. That is what the decision error you are making. This decision error is called as a type 1 error, alpha error, which is also called false negative or the producer risk. In simple word, if I will say, when you have the null hypothesis and from the null you are telling it to alternate. If you are telling null to alternate, then it's a type 1 error. Okay? योगेंद्र जी आप टीवी देख रहे हैं शायद कुछ सीरियल. Now the second case. Assumption training will be good and actually training is not good. So then there is a difference and this is a alternate hypothesis. Maybe someone, any of your friend and somebody is asking, or maybe I'm asking for feedback, guys. Okay, how's the training? When actually training is not good or you are not meeting your expectation, but you are telling I met my expectation. You are giving me the feedback, training is good. Then again, you are taking a wrong decision, which will be called as an type 2 error or beta error. Which is called as an false negative, sorry, false positive. And this will be called as a consumer risk. So these are the way we define the incorrect decision when statistics is not sync with the practical. So in short, if actually is an alternate hypothesis, but you are telling this as a null hypothesis, then this is a type 2 error or the beta error. These are the guys decision error will be taking. Tell me any question in case you have, you did not understand this.
Mr. Pankaj?
Yes, please.
So assumption training will be good.
Hmm.
Actual, is there any like because what you are talking about is extreme opposite, which is good or not good. Is there like other rating like best, good, or less satisfaction, something like that?
No,
Then,
we are not doing the ranking. We are not doing any ordering here.
So
We are
in-
just deciding because hypothesis you decide in the two way. Either it's a null or it's a alternate. There is no in between.
okay.
Pankaj, why it is first example null to alternate is alpha error, why it is not beta error?
This is how A plus B is defined. A is A, B is B. Statistics defined that whenever actually there is no difference means null hypothesis, but you are telling there is a difference. There is a difference means alternate hypothesis. In simple word, I was explaining you whenever there is a null hypothesis, but you are telling it's a alternate, then it's a type 1 error. These are the other synonym of that. Alpha error, false negative, or the producer risk. When there is no difference, then it's a null hypothesis. Now the second case, when there is a difference, that means it's an alternate hypothesis, but you are telling there is no difference, which means statistics is telling there is a difference.
Correct.
And you telling there is no difference, then it's a type 2 error or the beta error.
Okay, thank you.
All right. Any more question, guys? So we understood what are the decision error. Yes, please.
So in summary, type alpha error or type 1 error is mostly coming when the assumption and the actual data is reliable, but my decision is wrong depending on them.
Yes.
And the assumption in type 2, if the assumption and the actual data is not correlating, but I'm actually taking the actual data, which is actually is not correlating, as an actual as it was its assumption, as it's a good data.
Yes, you are right. Which means when something is true, you are telling that is false. It's type 1 error. When something is false and you are telling is true, then it's a type 2 error. Both the cases we are taking an incorrect decision only. Yes, please. Any other question?
Yeah, sorry, the type 1 error is also called producer risk, but what is the other name for the beta error? The consumer risk. Okay. Awesome.
Okay. Now, another which is very, very important thing we are going to learn. Hypothesis anatomy or the structure. Which are the hypothesis tests we perform in what condition? This is what is the main part of any of the black belt, because you will be performing lot of statistical analysis and then you will be taking the decision based on that. So which are the tests we perform in what condition? That's what we are going to learn now. So first thing, as I was telling in the hypothesis, you have three conditions: sample with the standard, two sample with each other, or three or more than three sample with each other. Let's say when you want to compare sample data with the standard data. So you have the sample data with some target or some standard value. Like as your quality target is 98%, you have collected the data of the quality. So what is the quality is coming, actual quality? Basis on that confidence interval, like this, you are comparing your target quality. They are same or they are different. That's what is the one sample with the standard I'm talking about. So there are a couple of tests which you perform. First, I will be writing the test name. Then I will be writing why we perform this. So the test name here is one sample t test. One sample t test we perform when you are comparing mean value, which means you are comparing average of the target with the average of your observed data. Because here we are comparing sample data with the standard. So you have a standard mean and you are comparing the sample data mean which you have collected. Then we use with the one sample t-test. In this condition, your data distribution should be normal. In this condition, your data distribution should be normal. Then we perform this. And your standard deviation is unknown. Which means we are not considering standard deviation. Data is normal.
So let's say we have 10,000 samples for the quality, and the average or mean is, let's say the target is 98, but it is 96. And the sample size we pulled out, let's say 10, and out of those 10, the mean is around 95 or 96. So on the basis of that, we can perform this, correct?
Yes, yes, absolutely. This condition will be performing. I will be doing all these tests practically with you. You will be understanding. First, let me complete this anatomy part, okay? Now, another test we do, one sample Z test. One sample Z test, again, we are comparing the mean only. My data is normal distributed, but here the standard deviation is known to me, that how much change I want to perform in the standard deviation. Maybe I want to reduce the standard deviation, I want to increase the standard deviation, and then I'm trying to validate how my process confidence interval will behave. So for that, we do the one sample Z test. Another test we perform is the one sample sign test. One sample sign test we perform when you are comparing the median. Let's say here, before that, let me write one sample Wilcoxon test. One sample Wilcoxon test you perform when you are trying to compare the median of a normal data. Standard deviation is known or unknown, doesn't matter here. Not applicable. You are comparing, your data is normally distributed, but you are comparing the median of that data. No, 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 no. Mean of a non-normal data. Sorry. This test we perform when you are comparing average of a non-normal data, then we perform the one sample Wilcoxon test. You use one sample sign test. When you are comparing the median of a non-normal data. Standard deviation here as well, not applicable. So you compare one sample sign test when you are comparing the median of a not normal data. In case you are looking for the variance comparison or standard deviation, both will be performed in the one test only, variance and standard deviation. For that, we use one sample variance test. In this case, your data normal or not normal is not applicable, neither your standard deviation is applicable. Straightforward, you can compare. In case you want to compare the defect rate on a scale of 0 to 1, then we use one sample Poisson rate test. Again, your sample data distribution or the standard deviation not applicable. In case you are looking for the percent rate or the proportion, then we compare one sample proportion test. In this one sample proportion test, we are comparing the proportion, and this data type is not applicable. These are the tests we perform when you are comparing the sample data with the standard data. If you compare mean or median, variance, defect rate, or proportion, whatever your target is. So these are the tests we'll be performing. Ask me a question in case anyone of you have.
In the number 6, sorry, no, I mean number 5. So the one sample variance test, we are actually comparing the variance or the standard deviation. So how is the standard deviation not applicable?
Applicable. Because you perform only one test, and one test only will give you two values. One, it will give the standard deviation, one, it will give the variance. Both the values it will give. Okay.
Yeah, I was saying, like, how is SD not applicable then?
Where it is, its SD is applicable. Here is the normality of the data condition is not applicable. Known or unknown is not applicable because you are already comparing the standard deviation of the sample.
Okay, yeah, that's what I was thinking. All right.
In proportion or percentage or in defect rate, or if we have to, run the sample test on, let's say, AST, which one is suitable here, like defect or portion or variance? Am I audible?
When you are using the Poisson rate test, then the scale of comparison is 0 to 1. When the same thing you are using in the proportion, the scale of comparison will be 0% to 100% because percentage is always 0 to 100. While the defect rate, the same percentage, you can call as in 0 to 1 as well. So when you want to see the result in a form of defect rate, which means your scale you are using 0 to 1. If you want to see the result in the percentage, then the scale you are using 0 to 100%. Otherwise, there is no difference in these two tests. Both the tests are same.
And let's say like my AST is 300 and target is 280. So I'm conducting a number 5 variance of 20 seconds, or is it number 6?
Okay. Can you just repeat the question one more time, please?
See, let's say the project is running on 300 seconds AST, and I have to take the AST to 280 seconds. And so I have to run the test on the samples, which is number 5, or any other test I have to
Number 1. Because you are comparing the average, AHT's average value. So against the average of 280 as an target, you want to compare where you are. So then one sample t-test. Target is 280, and actually whatever you have, you are comparing the mean. Mean means average value of that. When you are not concerned about the variability. If you are concerned about the variability as well, then you will be using the one sample Z test.
Okay, thank you. And let's say there is CSAT. Again, I'm running at 82%. My target is 89 or 90%. And then I have to go with these first and second test.
Yes, first one only. Again, you are looking for the 89 as an average.
Correct. Okay.
So then again, the one sample t-test. Okay. Now the second category, which I am going to explain you in this, when you compare two samples with each other. So you are comparing one sample data with second sample data. So what you are comparing first sample data with the second sample data. So here 7, 8, 9, 10, 11, 12, 13, 14. You will be using paired t-test. When you will be using paired t-test? When you compare again the mean here in the paired t-test, your data is normally distributed and the condition is before and after you are comparing. Situation is clearly stated before improvement and after improvement in case you want to compare the AHT. So before implementing any of the solution versus after implementing any of the solution, you will be doing the PRT test.
So this is the situation where we have applied the improvement actions, and after that we are comparing before where we were and now where we are after that, correct?
Yes.
All right, thank you.
Okay. So this is only before and after situation, and your sample size should be balanced sample. Balanced sample means if you have the before, you have the 25 sample, then after it has to be 25 sample. If there is a difference of any one sample, you cannot perform the PRT test. So for the PRT test, your before and after sample should be same. In case your before and after sample is not same, so there is an alternate to this, which is called as a two sample t-test. In two sample t-test also we compare the mean. Data is normal, which works on the unequal sample or unbalanced sample as well. So in case you have before and after, when the valence sample is not there, sample size is unequal, you can use two sample t-test. where the pair t-test will work only before and after. But the two sample t-test you can perform in any condition. You just have to have the two data, which is normally distributed, and you are going to compare the mean. There is another test which is called as an Mann-Whitney test. We perform when we are comparing the median of the data, and whenever you compare the median of the data, means data is not normally distributed. Before and after, equal, unequal, it doesn't matter here, not applicable. In case you are looking for the variance comparison or standard deviation comparison, then you will be using two sample variance test. In this case, you will have both the condition. If data is normal, you will be looking for the p-value of Bonnet test. If data is not normal, you will be looking for the p-value of the Levin's test. Only one test you are performing, two sample variance test. It will give you both the p-values. If your data is normal, then Bonnet test. If your data is not normal, then Levin's test. Now, in case you are looking for the defect rate, as before we have seen in the one sample test, then we'll be using two sample Poisson rate test. Data normal or not normal doesn't matter here. Similar way, if you are looking for the proportion, then you will be using two sample proportion test. You will be using two sample proportion test. All right, guys, clear? Doubt, question, please ask me. No? Okay. Let us understand another category. When you are comparing more than two samples with each other, when you are comparing three or more than three sample data with each other. So which test will be performing? First and foremost thing, we will be doing the test of equal variance. Test of equal variance will be doing, right? If your data is normally distributed, when you are comparing the variance or standard deviation, if data is normally distributed, then you will look for the p-value of multiple comparison in Minitab. In the same test of equal variance, you are comparing variance or standard deviation. If your data is not normal, then you will be looking for the p-value of Levin's test. This is what we'll be doing. There is another test which is called as an ANOVA test. ANOVA stands for analysis of variance. That means you are comparing the average value. Average value we always compare when data is normal. Or you will be using the Mott's median test, where you are going to compare the median, and for the median, data is supposed to be not normally distributed. So these are the 4 tests we perform when you have the 3 or more than 3 sample to compare. Any question here?
Hello.
Yes, please.
On
I will
practical
tell.
scenario, we have
Yes.
to identify all these parameter before performing the test.
Yes.
Tough job.
Another test I'm going to help you. I will explain, though generally we don't explain in the black belt, which is called as an Kruskal-Wallis test, where you are comparing the median ranking for the not normal data when we perform Kruskal-Wallis test. Okay. Are we clear till here? Any question, anyone? Ask me, please. Muna, how you are doing? All are catching or going over the head?
Surviving. Surviving.
Very difficult.
Well, my head is overblown with all of this, but I think we'll get there.
Yeah, you will get it. It's not difficult, because if I can remember who is the dumbest person on the earth, so then you can also remember. You are the intelligent people.
If you are the dumbest, then who we are?
No, sir.
Seriously, I did my green belt. It was not this deep at all. Like it was. Now I see how simple that was, and I thought that was hard. Never mind.
No, this is what we expect as a black belt, and
It
there's a
was
very,
more
very
greener.
high expectation, very high expectation from the black belt when you go into the industry. Okay. Now I will be moving to the some other categorical data kind of thing. So first thing I am explaining you about correlation and regression. In this category, the first test we plot the scatter plot. Scatter plot means you are looking for the graphical relationship. This is one of your 7QC tool as well, right? So you are looking for the graphical relationship between two variables when your Y variable is numerical, maybe continuous or maybe discrete, and your X variable is also a numerical variable. And you are looking for a graphical relationship between these two variables, then we plot the scatter plot. In case you are looking for the strength of relationship between these two variables, which is Y and X both are numerical, then we do the correlation analysis. In case you want to predict, if you know the value of Y, you want to predict the value of X, what should be based on the past data? Or if you know the value of X, you want to predict the value of Y based on the past data, when X and Y both are numeric, so then you will be using the regression analysis. Which is the equation? Equation of a straight line, you remember, Y is equal to mx plus c, or Y is equal to a plus bx, we call this. This equation we are going to learn. So when Y is equal to a plus bx, then your X is equal to, in case you want to predict X, will be your transform Y minus a divided by b. So this is what we will be learning in the regression equation. Another test which we are going to learn is your chi-square analysis. Chi-square analysis we perform when your what? First test is the goodness of fit test, which is also called as an one variable test, which is also called as an one variable test. I'm just writing here. We perform when y variable is count in nature and your x variable is categorical in nature. When y is count and x is categorical, then we perform the one variable test. In case your y and x both are count, if both are categorical, Minitab will automatically convert those categories into count and then it will calculate the statistics. Okay. So you ultimately dealing with the count only. If it's the category, you are converting that category into the numbers and then you are going ahead, which is also called as an, this is the test of independence. Sometimes we call this as a test of association or two variable test. Either these two variables are associated with each other or not. That is called your test of independence also, when both x or y are count, which may be categorical in nature, and Minitab will automatically convert this categorical data into the count data for this test. The third test we perform is the cross tabulation.
X and Y count. No?
Yes, x and y both are count.
I think it's
Okay,
Y and
this
Y.
should be x. Sorry. Okay, thank you. Cross tabulation. Cross tabulation, there is no name. When your y is categorical, which again Minitab will automatically convert that into the count. Your x is also categorical. And the same time, you have the layer as well. When these x and y, which is itself is a category, they are coming from more than one category. Like as you have the type of defect and which product you are manufacturing. So type of defect can be multiple, product can be multiple, and you are comparing between the day and night production, which means there's the one layer is for the day production, one layer is for the night production. So when you both the data x and y are categorical, which comes in more than one category, that is your layer, then we perform the cross tabulation analysis. Last thing which I am going to explain you now.
This is the last one. No?
This is the last one. This is, you will be performing logistics regression. When you wanted to calculate the probability of any categorical data, calculating the probability of the numbers is very easy, but you want to calculate the probability of the text, then we perform the logistic regression. So there are three types of logistic regression we'll be doing. One is the binary logistics regression. Binary logistic regression we perform when we wanted to find the probability of 0 or 1, yes or no, good or bad. In this case, your Y variable output is binary in nature, like as material will be rejected or material will pass, where the X variable is numerical in nature, maybe based on the batch size, how much is the batch, how many of the pieces you have produced in a day. Basis on that, you want to find out what is the probability that batch will pass or batch will fail. So when Y is binary, X is numerical, then we perform binary logistic regression. Similar way, if your data is ordinal in nature, which means sequential data in an order, then we perform ordinal logistic regression. X still will be numerical and your Y will become ordinal here. In case your data is categorical, which means nominal, more than 2 category independent. Nominal means noun. So Y will become your nominal and X will be your numerical. So when Y is nominal and X is numerical, then we perform nominal logistic regression. And then we'll be trying to find out the probability of what is the probability of each of these nominal categories. These are the tests, guys. I will be explaining you practically one by one. Question for me.
There are so many.
Yes, sir, there are so many, but I can't help. This is what the way black belt is. It's designed in like this way. So we need to learn all kind of analysis. I will be taking the example of all the analysis. So I have downloaded one data from kaggle.com itself, and which is your student performance. So this data I am going to use to explain you how you will be performing all these kind of analysis. So I'm adding this data into your Excel sheet. You just have a look at the data and then ask me the question in case anyone who do not understand this data. I think today I will close the session here only, maybe 5-7 minutes early. Why? Because if you people are okay, I can start explaining you the test as well. I'm absolutely fine. But I feel that you people should take rest now for today at least.
Yes, sir.
Understand this data. Read carefully this data. What is this data is? As per this data, try and find out which test will fit. Or if you want to fit, like as eeny, meeny, miny, mo, any of the number is coming, maybe I want to fit the regression. I want to fit the goodness of fit. I want to fit the cross tabulation. I want to fit the ordinal logistic regression. Then which Y should be there, which X should be there, so that I can perform this test. That kind of work I would be expecting from you people to come when you will come back on Monday, that much of the readiness of preparation you should have done, which means you have done this exercise at home. Try to find out based on this data is numerical, this data is categorical. I want to compare the categorical against the numerical, so which test? Or if you want to compare numerical against the categorical, to which test? If you want to compare category 1 and category 2, which test? If you want to compare numerical 1 and numerical 2, then which test? So that is what my expectation, guys, from you people. So you have the name of all test, you have the condition of all test. You just try, like as against this, you write, okay, here should be my this value, here should be my this value, then I can perform the pair t test or the one sample t test or maybe one sample variance test. Please do that.
Sure.
If you really want to understand this clearly, please do that homework. If you have done this homework, you have done. Maybe you did not understand, you understand 15-20%, but you should be able to catch immediately what I'm explaining if you have done this homework.
Sure, sir.
Sure, sir. I'll try.
Okay, so I will be closing now here and I will be posting this Excel sheet right away into your chat box. Anyone present in this my Excel sheet? Rajesh CR, you there? Mohammad Al Sayed? Ajit Singh, anyone? Please tell me your name in case this is the row number N I am looking for. File and here you go. In your chat, Excel sheet is done. And I will be sharing the mini tab as well right away in your chat box. Go with the mini tab. Mini tab file is also in your chat box, guys. Done. Question for me?
Pankaj, can we get the recording at the earliest?
I will ask this team, backend team, that you people, even you can drop a message. Can we?
Okay. Sure, I will put one message there in the group.
Right, please do that so that they will have a pressure. Okay, they will try and download this early in the morning tomorrow, because Saturday, Sunday generally it's I think tomorrow, day after tomorrow is a non-working day for them. But I will ask them personally as well that it's very important to see the recording for the Monday class, so they will try to do this. But yes, please do drop a message in the group.
Sure. Thank you so much.
Thank you so much.
Sir, this mini tab file, which is where
Ji.
to open, like I have downloaded that. Should I have to open with the Excel?
No, you cannot open with the Excel. For that, you have to have the mini tab installed in your system. Like as in my system, if I check, this is the Minitab app I have installed.
Okay.
And then only you can open this file.
All right. Thank you.
But the people who already have the Minitab, they can open it. The people don't have the Minitab, they can download a trial version, which is applicable for 30 days. After that, you have to purchase a license for that.
We can change the even number and email, then use another one.
Probably, so then you need to think about that your directories should not be left in the C drive. So then if you remove all these directories or updates, then you can do that basis on that as well.
All right, so thank you.
All right, guys, thank you so much. And
Sir,
I
just
will
ask you to send it on WhatsApp as well. For some reason, whenever I save it from Zoom, it does not save properly. But from
Yes.
WhatsApp, I can just email it to myself.
I will do.
Mr. Pankaj, attend. Erin?
Sorry, miss. Just a second. Erin. Yep, thank you. Anyone else, guys? Who is present? Imran Ahmed? Imran is not there today. Manisit is not there. Mohammad Al Sayed? Not yet. Mohammad Al Sayed absent.
I have posted the Excel on the WhatsApp.
Okay, great. Thank you so much, Hassan. You reduced my work, though I will also post. Rajesh CR absent, and these 4 people are absent. Okay, guys, thank you so much, and I'll see you again tomorrow. Till the time, bye-bye, take care, and have a good night, and I will see you tomorrow. Okay.
Bye, sir.
Bye.
Good night.
Bye-bye. Good night.
Sorry, sir. Tomorrow got class, eh?
Yeah, tomorrow no class. Tomorrow means Monday. So
Oh, okay.
next class in my calendar is August 15, Monday.
Okay. Thank you. Thank you so much.
Today's 12. Thank you. Bye-bye. Take care.
Bye.